This lecture is going to cover ionic naming, specifically only ionic naming with our type 1 metals. So if you think to your ion packet, these are going to be the ones that always have the same charge. Typically the ones that we can just use the periodic table to see. So you may want to have your ion packet out so you can see those charges of those metal ions, or you could use a periodic table. Either one would be fine, but you are going to need to know charges. So we're starting off with binary ionic naming. So these are ionic compounds that are formed from a cation and an anion. And typically what we're going to see with that is that's a metal in a nonmetal. Some things to just write down so we can reference in a little bit is that your anion or your nonmetal in this situation, your ending is going to be an "ide." So we've been changing those endings a lot, so that's not going to change with this type of naming either. Another thing you have to do is keep track of the charges of the ions. That's why I asked you to get out your ion packet or a periodic table. Because what we're going to look for in the end is for our charges of the metal and the nonmetal to cancel out or equal 0. So a few tips when we are writing the formula. It helps if we always write out the charges above our ions, and I'll show you what I mean by that in a second. But this is something that I see a lot of students skip this step, and it hurts us in the long run. So I'm going to ask that you really do this step. It's going to save you a lot of time in the end, and you're also going to end up with a lot more correct answers. It really, really does help. I know it takes just a second longer, but it is worth that little bit of time. And then just a reminder is your charges must cancel. Okay, so naming the compounds, and remember again, this is with just our type 1 metals. You'll look at type 2 here in a little bit. So when we are naming a compound like this, unlike covalent, if it's ionic, we are not using prefixes. So how would I know if it's ionic or covalent? Well, if you think back, covalent has 2 nonmetals and ionic has a metal and a nonmetal. So the moment you see that it has a metal, you know it's ionic. You are not using prefixes. So when you are going to name an ionic compound, you name the metal first. So K is potassium. So P. Oh, sorry guys. And then O is oxygen. But if you remember back to our rules, we're going to change our anion or non-metal. We're going to change that ending. So this is potassium oxide. And then you're done. So we don't have to use those prefixes to identify how many of either one of them they are. And you'll see why that is when we go the other way. Okay, so here's our second one. So you go back to name the metal, and you're going to notice the metal's always going to be listed first. So that is sodium. Then you name your nonmetal. That's bromine, but because it's an anion, we're going to change its ending. So it's bromide. And it's as easy as that. So here's 2 examples. I want you to write these down, pause this, come back, and see if you got your answers correct. All right, so here are your answers for these 2. So if you take a look at what I did here, named the metal first, so that's calcium, named the nonmetal second, and then my ending changed to "ide." So instead of it being fluorine, it's fluoride. Here, name my metal aluminum, my nonmetal oxygen, change that ending to "IDE." So now let's go the other way. So what you've noticed at this point is your cation is listed first. Your anion always comes second in that name. And then you are going to adjust your subscripts. So we're going to look at what those subscripts are in a second, but make sure that you have your ion packet out or your periodic table. So the first thing that I'm going to do once I see what compound I need to write the formula for is I'm going to write the charges above it. So if you use your periodic table, you're going to know that cesium has a +1 charge and chlorine, that's not right, chlorine has a -1 charge. So remember, our charges have to cancel. So if your charges are equal to start with, your plus and your minus equal out, you don't have to do anything. All you're going to do is write your symbols. CS, Cl. And then I'm done. Now you are going to have situations that are going to come up where your charges are not going to cancel. So let's see how we handle that. So magnesium, I know has a +2 charge. Fluoride, I know has a -1. So I have to do something here to help get my charges to cancel. So what I'm going to do is I'm going to call this crossing my charges. Okay. So I'm going to give my 2 to the fluoride and I'm going to give my 1 to the magnesium. So now look and see what happens. So I'm going to still write out my metal first. I crossed my 1 over, so I'm going to say that I have 1 magnesium and 2 fluorides. So I took my charges and I crossed them and made them the subscripts of the opposite one. So the reason we do that, let's look really quick. If I have 1 magnesium, that has a +2 charge, right? If I have 2 fluorines, I have 2 fluorines times -1, because remember we said that each one's -1, and that gives me a -2 charge. And now our charges cancel. So when we cross those charges, it helps with making sure they cancel. So if you feel comfortable, go ahead and give these two a shot on your own and then check your answers. Okay, so here are your answers for these. So magnesium chloride would be MgCl2 because we crossed those charges and made them into subscripts on the opposite. Potassium nitride would be K3N, same thing. We crossed our charges and made them subscripts on the opposite. So go ahead and give some of the binary practice problems a shot, and then you're going to also look at another lecture that's going to look at if our metals are type 2, meaning the ones that have Roman numerals, they have different charges. So those we're going to handle in a similar way, but there are some differences, so I put them separately to kind of give you a way to define them. So go ahead, give some binary ones a shot, and then try those ones with type 2.